In this podcast, we'll find all real and complex roots of an equation. When we're finding zeros of a polynomial, we call it zeros. When we're finding where that equation is equal to zero, we call it a root of the equation, but the process is really the same. We can use the same theorems and same strategies as we have in the previous examples. So first thing I want to check for is the rational roots here. Again, we're looking at that last coefficient over that first coefficient. It's in the form of plus or minus a factor of 9 divided by a factor of 2. So we should have plus or minus. Factors of 9 are 1, 3, or 9. Factors of 2 are 1 or 2. So combining them all together, we should have 1 over 1, which is 1, 1 over 2, 3 over 1, 3 over 2, 9 over 1, or 9 over 2. And again, plus or minus, we don't know the sign, whether they should be positive or negative roots. Next, we can look at the number of positive roots. Well, that's the sign changes. In this case, there's only one sign change. So we can see there should be exactly 1, since there was exactly one sign change in the original equation. If we're looking at negative roots, well, again, really we're thinking replacing x with negative x. I'm looking at 2x to the fourth minus 5x cubed plus 3x squared minus 15x minus 9. Well, sign changes, we have 1 between the positive 2 and negative 5, 1 from the negative 5 to positive 3, and a third one from positive 3 to negative 15. Notice between negative 15 and negative 9, there isn't a sign change. So we could have at most 3, or because there could be complex roots, we could have minus an even number, minus 2, we could have 1. Either 3 or 1 negative root with 2 complex. So putting this all together, let's find the roots. And we want to also check for the multiplicity, find how often this is a root. So using our synthetic division, since I know there's exactly one positive root, let's check with that first. So I have 2, 5, 3, 15, and negative 9 from my synthetic division. And let's test 1 and see if that works for a positive root. Well, if we check, we notice it gets very big very, very quickly. So in fact, yeah, 1 won't be a root. So we know there's going to be a positive root. Let's try maybe instead 1/2 for the next one. So same setup using synthetic division so that we can check quickly and find the remaining piece when we check. So bring down the 2. 2 times 1/2 is 1. Add it. 6. 6 times 1/2 is 3. Add it. 6. 6 times 1/2 is 3. Add it. 18. 1/2 times 18 gives me 9. And so, yep, I get a 0 at the end. That tells me 1/2 is a root of multiplicity 1. I don't need to check to see if it's a double multiplicity root here because I knew there was exactly one positive root. We'll now check the negative roots in the remaining polynomial 2, 6, 6, 18. Using my list of rational possible roots, I can try negative 1. Bring down the first number, I get negative 2. And we can see, well, this isn't going to work. So negative 1 is not a root of this expression. I don't need to check negative 2 since it wasn't one of my possible rational values. Let's maybe try negative 1/2 just to see if it works. Again, bring down the 2 first. 2 times negative 1/2 is negative 1, should get a 5. 5 times negative 1/2 gives me negative 2.5. You can see it's starting to get a little bit messy. When I add those together, I should get 3.5, half of 3.5. Still getting very, very messy. And you can see, well, yeah, this isn't going to work. So negative 1/2 is not a root. Similarly, since I can see that the halves really aren't working, I probably don't want to try negative 3/2 just now. Let's try a whole number and see what we can get from there. So the next whole number to try would be negative 3. So with the synthetic division, bring it down. Negative 3 times 2 gives me negative 6. Add it, I should get a 0. 3 times 0 gives me 0. Bring down the 6. And negative 3 times 6 gives me negative 18. So yeah, that one's good. That tells me negative 3 is a root. Again, at this point, I'm left with a quadratic, 2x squared plus 6, which should be equal to 0. Rather than testing with synthetic division, once I get to a quadratic, use quadratic formula, completing the square, whatever is easiest. I should get 2x squared is equal to negative 6. Dividing both sides by 2, x squared should be negative 3. It looks like my roots here are x could be negative I times the square root of 3, or positive I times the square root of 3. Again, our original polynomial was degree 4. We found 4 roots. So the roots to the original expression, we found first the 1/2, then we found the negative 3, we found the negative I times the square root of 3, and we found positive I times the square root of 3. And we know each of those have multiplicity 1.